Okay, video for Simon Baghurst, and I hope I pronounced your name right, Simon, and David Ishvac talking about setback on WeatherComp. This is a pictorial representation of the WeatherComp curve on the Viessmann. This is the one by default. The boiler arrives at 1.4, which is 55-35 design. And I have to apologise here because I've been telling everyone 1.4 is 50-30, and in fact I'm 5 degrees out, so my apologies for that mistake. In fact, that would be 1.2. What I find is that almost all the boilers I install run on 1.4 with the existing radiators, which means that most radiators are or were, for the design they were supposed to be done oversized, but are still slightly undersized for 50-30, but so close no one would bother altering everything. So the design is actually at 55-35 for almost all the radiators I come across in my area. Right, okay, so David Ishvac's made a comment saying that the heating is on all the time, which is kind of misleading, and but it's not totally untrue. So basically the system is always active. It's always monitoring, always looking, always looking at what's going on outside, and it's always acting appropriately to the outside conditions in response to what you're asking it to do on the inside of the house. So what this means is if I tell it that I don't need my house to be heated, I just set the boiler setback to 3, which is the default on the boiler, and unless the outside temperature goes to 3 or below, the boiler doesn't bother waking up. It's just having a nice rest. Apart from looking at the outside temperature, it's not going to fire up, it's not going to run the pump, it's just going to sit there basically off. Now, building research establishment, when I did the energy efficiency professional training at building research some years ago, advised us that no property should be allowed to fall below 17 degrees. And I still stick to that. I think all the Honeywell equipment arrives at the setback of 16 degrees as a standard program, even though Viessmann arrive at 3. So I'm not quite sure why Viessmann go for the 3, but they do. And so if I set my heating to 17, at the moment you can see here set to about 21, 22. We can come out of here, see what's set to 22. So I've got the internal temperature set to 22, 4 degrees outside. Currently got a flow temperature of 49 degrees from my boiler. And that's just coming down from having heated hot water, so I might drop back a little bit yet as well. Usually expected to be a degree or so lower than that at 4 degrees outside. But if I reduce the room temperature for the setback to 17, that is going to actually give me, you can hear the boiler dropping off now, it's already backing right off. So now what the boiler is going to be doing is going to be giving me a flow temperature of about maybe 37 degrees. So whatever energy is required to maintain my house at 17 is what the boiler will now give me. And obviously that's going to be very, very little. Probably only one boiler on the market that could actually do that, and that would be this one, because I can go down to 1.7, 1.8 kilowatts, which is probably about the amount I'd need in very, very cold weather to keep my house at 17. And that is still energy used. If I actually want it to go off and I want it to go below 17, and I want to risk damaging my property and the contents of my property by having low temperatures and the associated discomfort of that, I can choose to do so. I can have my boiler off or on a lower setback. It's completely controllable. Now, the other thing that people get wrong is what happens when it's finished. So when we've come off of setback, sorry, let's go back to this. When we come back off a setback and the boiler sees us suddenly wanting a period of 22, it doesn't just fire up to give us the temperature that we need for 22. It goes into a recovery mode, a boost mode. So it actually provides extra temperature, extra energy to raise the temperature from the setback temperature to the new target temperature. So it's not that there's a big lag or any of these other problems that people keep talking about. This just doesn't happen. You've got what it says and it does what it says, and it does it really efficiently and well, and you just have total comfort. The temperature in my house, always within 1 degree centigrade. Almost every house I do, always in 1 degree centigrade of that target temperature. Sometimes they're a little bit fiddly. So if I go into this heating curve. So when I first set these up, well, to be fair, most of them we leave on 1.4 and that's it. They work perfectly. But there are occasions when they don't. So let's say someone's got really small radiators in their property, and we're preempting that. Normally I'm looking around the house and thinking this is going to be a bad one, so I might have left the boiler set on, let's say, 1.8. And then my instruction to the customer is, look, if your boiler's set to meet the house at 22 and the house is 24, you need to reduce this curve. If you reduce the curve and then the house is targeted to be 22 and it's 22, you've got the right curve. If you've reduced the curve and the house is now colder than 22, you went too far down, and that's it. So basically, they can actually just adjust this maybe 2 or 3 times, and the best time is in the very cold weather. If you look at the curve here, if we look at, say, -20 to exaggerate things, actually let's go for this -10. So -10, a slight distance on the curve gives a bigger increment of temperature change than it does at a higher increment. So therefore we're much more responsive at lower temperatures, and because everything merges back to the original point, obviously there's less and less margin for error as you go back up the temperature ranges. So a wider range of curves could give you good comfort and good accuracy at higher temperatures, but you've got to be much more on the ball at these very low temperatures with your setting. So if we set these up winter time, when it's around plus a couple of degrees, minus a couple of degrees, that's going to be the correct setting for the boiler for a long time. And this is the only complication with WeatherComp, is to get this little adjustment done, and really it's not that big a deal. So the results are well worth the invested time. So I hope that helps. So no, the boiler doesn't have to be on all the time. Yes, it can be on all the time. Yes, it's always monitoring. It's always there to protect you and protect your property. It will always do what you ask it to do, and it will do it perfectly, and it will do it with the best efficiency and the highest of comfort.